Hi everyone, I hope you're enjoying the conference so far. My name is Theodore, I'm coming from Athens, Greece. Try to proclaim myself as an independent software developer. I'm also the head engineer of Proxima Analytics. We are launching a web analytics platform which is privacy first, ethical as we can be. And out of curiosity, how many of you have you ever used Next.js? Like hands? Yeah, most of the people in this room. So today we're going to speak about how you can scale an application from 1 up to a few million users without breaking the bank, without using any major vendors or so. And I'm always trying to find out like a really catchy title for my talks. And I actually remembered this album. This is called It Takes a Nation of Millions to Hold Us Back. It's from Public Enemy. It was released in 1988. And it's a really breakthrough album, right? Because back in the days in the music industry, everyone was telling the artists that you have to do gangster rap, you have to do, party music and stuff like that. And it was breakthrough because Public Enemy came out with a highly political record, talking about oppression, talking about police brutality, things like that. And still, people could relate with their music. They made a huge success. And I can see the analogy there, right? Because more or less, if you're into the Next.js community, you know that it's run by Vercel, it's maintained mostly by Vercel. They're following their compromises. You have a few options with major providers. If you want to deploy your application, you can use Vercel, Cloudflare, Netlify, AWS if you want to feel the pain and put more money on Lex Luthor, aka Jeff Bezos. And then if you have an application in place and you're ready to go, you also have to think a lot more stuff. Like you have to think about databases, error tracking, additional components in your stack that actually they won't make your life easier. So we have to think ourselves, is it the only way that we can go through and why? Because we felt that same pain where we were developing our own software. So just to give you a rough idea about the initiative, basically it's much cheaper. Nowadays, cloud computing is way more cheap. It's portable, so in case you're falling into price gouging from your vendor, you can just change vendor easily. If you're relying on open source technologies, it's versatile, which means that you can run your Next.js application along with Node.js server, maybe a Python script or Golang or whatever you want to. So you have that versatility in place. You don't have lock-ins as well. So you don't have to rely on vendor-specific technologies and stuff like that. And finally, that's the last point, which is actually based on our software. It's privacy first, which means because we're relying on European legal laws, we don't want any overseas data transmissions for our clients and for the people using our analytics software. So we can set up a goal, and that goal can relate with some people in the room. So the goal is to try to scale like in a linear fashion. You don't have to actually target like millions of users, like your Black Friday day from day one. The whole idea behind that is that we can use Next.js because it provides out-of-the-box client integration, server integration, everything you want to. We want to run like a very basic software as a service template with a database, some cron jobs maybe, some Stripe integration, you name it. Just a very basic setup. And as you can see in the chart, we want to actually spend money as we're growing. So we don't have to, from day one, to start thinking about what will come up in the next years or so. Just build our user base and then move along. And during this talk, you will hear some tools here and there. I actually want to tell you that you have to make your own work, like do your own research, bring up the tools that you and your teams are familiar with, so don't stick up with these tools. You have to move along based on your project, your needs, your business model, and so on. And actually, I have some code samples that you can follow along that they're here for reference. So there's a complete series of articles that I'm bringing up. So all the code samples are here as an example, actually. So Without further ado, let's start building. We'll start with user number 1, and basically that's you and every single person that is going to touch your code base. Next.js comes with great DX out of the box. So you have a hot module reloaded and so on. Like, it's a great tool to get started with. During this talk, we will also follow some best practices that they're coming from the 12-factor app playbook, more or less some good practice to follow when you want to deploy and scale your application. So in order to provide our dev environment, we can start simple. You can provide all the sidecars, like if you have a database, a proxy layer, an API gateway, everything that your developers need to set up their local environment, just you can use Docker Compose in order to describe your infrastructure. I'm sorry. Then we can have environmental variables in order to store secrets. You can use an external tool like Haskell Vault, .env Vault, or maybe a password manager. So we can describe the secrets for our dev, staging, and production environments. We also need to log our dependencies. That can be a breakthrough. So you need to lock down your dependencies inside your system so you don't have any side effects, any breakthroughs as you keep growing up. And finally, it's a really good idea if you could establish some checks, like establishing really early a CI/CD pipeline, so you can do some preliminary checks for your build sizes, for your JavaScript build time, and so on. Here, I'm just using Bundle Analyzer, setting up a budget in order to find out if any of our dependencies are growing like extremely fast. And now that you have, you're during development, you want to start with your first users, like your first 10 users. The numbers are more or less arbitrary. It's based on your needs, as I said before. So it's time to actually get started in deploying our application, right? Next.js comes along with a standalone mode, which means that during build time, we can actually create a build folder containing all the code for our application in just one file. So we can set up this in the Next.js config. And then we can use Docker in order to provide an isolated and versatile way of deploying our application. This is a stripped down version of the Docker file. I have a complete write-up in my blog. There's a link down there. So basically, we need to start with the base Node.js image. We can split the image manifest into steps, so we can leverage the building casting mechanisms of Docker. We'll start from the base. Next up, we'll install all our dependencies. We will provide a building step where we're actually building our application. And finally, the very last step, we're exposing the port and running the application. In the full-blown example, we're also tackle down a few things like permissions and things like that. And if you want to actually, you have to build the image file using a single line of code and then validate that your image has been built up. And now that we have our base there, you can also, by the way, work with versions. So you can have different versions for staging, productions, and so on. And then using a registry like Docker Hub or a private registry maybe from GitHub, you can publish your image and it's ready to get consumed. So for a basic setup, we won't actually get nuts. A single VM, it's more or less €5 per month. One core, just 2 gigabytes of RAM. In order to deploy everything, we can use, there are a bunch of tools out there. By the way, everyone who talks about JS fatigue and haven't got into building tools and infrastructure tools has no idea at all. There are so many tools out there. So we can use Docker Compose in order to replicate our dev environment. We can use Doku, Coolify, Kamal, whatever you want to. I'm going to use Coolify, which is actually an open source Heroku alternative. It's super easy to use, super fun to use, and it will help us go on. We have a DNS provider, so we'll set up our DNS, our domain name, targeting our hosting environment, and we are going to actually deploy our application in the database on the same machine because we have just 10 users. We want to validate our idea. In order to deploy Coolify, we just have to SSH inside your VM, right? And it's a single installation line. It will install Docker engine, and it will guide you through the installation process, and you have a really nice UI that you can deploy your database just with clicks, provide the Docker image, and run your application. Great, so now we have a running application. And after beta, we want to actually scale our application and open it up to the world, right? This setup is more or less the same as before. We don't have to do much. We can set up a CDN, a content delivery network. There are a few vendors out there, Cloudflare, Bunny, Fastly, you name it. So basically, we want to cast all our static assets across the globe, so the users feel that snappy look and feel inside our application. And also, we need to provide some sort of monitoring. We need to track down our CPU, memory, disk operations, and so on. This is crucial because we want to have something to know when we have to scale up or down based on our needs. You can use, there are a bunch of tools out there, Grafana Cloud, New Relic, Datadog. Basically, we're using Coolify in order to also monitor our setup. So we have Prometheus, Loki, and Grafana installation, so we can track all the metrics from our cluster. Cool, and everything keeps, everything keeps growing. You have more money to spend inside your application. Let's talk about the next step. This is the simplest one, maybe. So since you have monitoring in place, you can actually detect your pain points. Is your application CPU hungry, or it's memory intensive? And you can actually just scale up the VM, provide more memory, provide more cores, try to adjust with your needs. Maybe you actually over-engineered something and you need to scale down your machine. This is not so crucial, but it actually allows you to have that flexibility that we have talked before. Next step. This is more or less the way we want to handle things linear. So as I said before, we have our database inside our machine. Now we need to focus removing all the resources and just provide a cluster that's for your application. So you can have just your application running inside the VM, and you can use an external vendor like Supabase, or if you're using Postgres, or any other vendor, or actually self-host your machine in an isolated environment. That means our application just runs inside our VM. We don't rely on database hiccups and so on. Also, we need to make our application stateless, which means that we don't have to have dependencies relying each other in our API layer. This is also nice to have. That's we call it grooming. So basically, you and your team can actually allocate a few hours per month or per week in order to provide some nice go-tos inside your code base. That's really, really crucial because it can save you lots of money, lots of effort in the long run. As an example, here we have introduced Redis, so we don't have to actually, if we have a heavyweight query, we don't want to actually spend so many resources inside our database cluster, and also reduce the memory consumption inside our machine. Another rough idea would be to introduce database pooling. We're using Drizzle in this example. So instead of having just one connection, we can introduce database pooling in order to reduce the network effort. And also keep an eye on your dependencies. That's also really crucial. There might be security releases, or maybe you might find out that there's a barrel import that it's suffocating your build times. So it's always really nice to keep an eye on your dependencies and upgrade when it's possible, instead of upgrading all your dependencies at once and introducing side effects inside your code base. And I hope you're not bored up until now, because here is where things get funny, as fun they can get when we're talking about systems, right? We'll start with our first big moving on. Up until now, we were talking just about a single VM. Now it's time to move into a more versatile and more, if we can say so, highly available setup. So the whole idea is that we want to provide multi-node setups instead of having just one machine. We are going to introduce load balancing. So we have a load balancer, mostly provided by your provider, Hetzner or Scaleway. They're providing out-of-the-box load balancers. And we're also introducing infrastructure as code. Infrastructure as code is a way to determine your whole infrastructure setup. So we can have a Git repository describing our whole setup. We can use a tool like Terraform, Pulumi, Ansible, OpenTofu, which would actually describe all the moving components inside our infrastructure. This is really crucial because they're providing state, so you have, you can debug stuff because you can replicate the whole state of one command. It also allows to run everything manually or through your CI/CD pipeline. And it's also really important for our next steps. Just to give you a visual perspective, on the very top, we have our DNS provider, which targets down a load balancer, and underneath, we have our servers that are listening to the load balancer. You can actually configure your load balancer to route roaming the requests, or try to find out which node has it's not so overloaded with traffic. And just to give you a perspective, once we have Terraform our configuration file in place, and we'll start bootstrapping our infrastructure, at the very bottom line, we have the IPs of the hosting VMs and the load balancer IP. In order to deploy everything, I'll try to pass through some really good and cool tools. So for this example, we're going to use Kamal. Kamal is a tool deployed by 37 Singlands. They have a really wonderful write-up about how they moved away from AWS because of the costs and the versatility. So it's pretty straightforward to install it through our Terraform setup. And once we're done, we can have a really simple configuration file. It's YAML-based. So basically, we're saying, hey, this is my Docker file. I have the IPs of the VMs in place. If you're running a private Docker registry, you can set up your username, your password, and exposing the board, and basically that's it. You can also deploy any sidecars like databases and stuff like that. They're also providing out-of-the-box integration with traffic. So you have routing in place, networking in place. It's a real great tool to move on. And, oh, I'm sorry. And now it's time to actually try to build our own Vercel. We can do so, to be honest. Like we don't have edge computing, we don't have that elasticity that you can run your Lambda functions like infinitely and so on. But we can actually try our best to provide a highly available setup and try to auto-scale our cluster. Because right now you have like a certain amount of nodes, and basically that's it. The whole idea behind this setup is that we can actually use our DNS provider and target, instead of targeting one cluster, we can actually target more than one cluster, and provide that setup with different data centers around the globe. We're also going to use infrastructure as code, but this time we can pick up, hey, I want to deploy something into the Warsaw data center and the Paris one. We also have our CDN in place, so we have the canceling mechanism for static files all around the globe. And if you feel like super crazy or something, you can try Kubernetes, Kamal as well, or maybe Haskell Nora, which are both really good tools for that kind of purpose. Our initiative would be as follows. We will pseudo provide the elasticity part. So imagine that you have a cluster in place, and for some reason it's Black Friday, right? You have too many requests hitting your servers. It's like CPU intensive or memory intensive. Because we have the monitoring in place, we can set up alerts and say, hey, the Warsaw data center is suffocating as we speak. Okay, run the CI/CD pipeline. In 2 minutes or so, you can add more nodes inside the cluster, update the load balancer, and here you go. Basically, we're following the same setup over and over again. We can create ephemeral VMs, try to be as scalable as possible, if I can say so. And the setup I brought before, so here we have our DNS. You can actually set up your DNS with Bunny or Cloudflare in order to say, hey, connect the user with the closest data center so they don't suffer from network issues and the distance. And once we get back that event from our monitoring system, 2 more servers are attached to its cluster. I know that sounds a lot, and they're like 2 too many things talking about, too many names, too many tools, and things like that. I'm trying to actually document our whole trip for moving along into our own cloud, if I can say so. That's gonna be like, I have written a series of articles trying to publish them as regular as possible. I have the very first piece up and running in my blog and Dev2 as well. And just to give you a perspective, that's a really crowded slide. But this is more or less our setup for proximal analytics. We have 12 app servers in 2 regions, Germany and Paris. We also running our back office server, which is more or less our support system, some Stripe hooks, things like that. 3 databases, 1 Postgres, 1 Redis, 1 ClickHouse. We're using GitHub Actions to bootstrap everything. We are also accommodating 2 providers based in the EU, owned by EU companies, Hetzner and Scaleway. 3 Next.js applications, I know that's too much. 3 Node.js applications, lots of background jobs, and we're actually using Nomad and Coolify to do so. So let's bring up some numbers, right? Like actual numbers. 24 cores, more than 60 gigabytes of RAM running inside our clusters, 30 terabytes of disk. We're in closed beta, but we're at the moment working with more or less 1 million hits per month. And our setup will get us through up to a few million hits. It was our decision to spend up like a portion of we're bootstrapped, so we have spent some money on contractors, mostly because I'm the main developer of the application, so I didn't want to, I wanted to focus on coding, but more or less everything is like super straightforward if you have the time to invest. And just to give you a perspective, basically this kind of setup, it's actually impossible to run in Vercel at this very basic setup. But if you would choose to run with AWS, that would be more than 4,000 euros per month, 18,000 zloty, and our setup actually right now costs more or less 450 or about 2,000 zloty. I don't want to bother you too much with more details. Just to wrap up, I have a really weird thought in my head that most of the times we're thinking that we're developers, most of us in that room. We're followers, consumers, or clients, right? We're just following. Someone says, this is the way to do things, and you have to follow along. This is how you should build your application. And I truly believe that monopolies are not actually working. They say, in no ways, they're not pushing us forward. And I think that as we progress and as we're coming together, it's a really good idea to bring up more versatility, more ways to build stuff, to really build cool stuff. And I really want to thank you so much for your time and patience and for this wonderful conference.